Thanks everybody for joining me here today. We have a new exciting set of announcements around our Oracle Cloud Observability and Management platform. The good thing is we've got more than just me talking to you about some slides. We actually have a huge number of demos that kind of showcase this stuff. Sometimes, as you know, one of the downsides of infrastructure is that it's not very visually appealing. The cool part about the stuff we're talking about today is it actually looks really cool as well. We're talking about our overall observability and management platform. I want to start with a baseline of where we're at in the industry. So if you actually talk to different customers, and here we have some analyst data and different quotes from different providers around what's going on in the industry, the reality is there are more tools than ever, right? You've got tools for on-premise, you've got tools for the cloud, you've got tools for different cloud providers, each one. There's cross-cloud tools. There's never been a time in history where there's more options for how you can observe and manage your applications and your workloads. At the same time, as you can see here, there are a ton of outages that are still happening with customers. The vast majority of issues are still reported by end users, and fewer than 15% of organizations are satisfied with the actual amount of monitoring and insight they have into their workloads. So we've got more tools available than ever before. At the same time, it's not working for customers. So why is that? Well, it's because the new world that we live in has become much more complex, right? Think about your environment. You have a huge number of different programming languages. Well, that makes it hard to find expertise for each of these different technologies. You end up with these observability solutions, but they end up being siloed, right? This is a thing that helps you with analyzing these types of logs. This one is for your time series data, but they don't work together. So you end up having to have multiple tools. All of these different tools end up with data in a variety of different silos. So your time series data doesn't correlate with your log data. Your log data doesn't correlate with what's happening in your database. What's going on with your end-to-end tracing framework doesn't integrate with any of that. And so then when you have identified a problem, it's very hard to figure out which part of your platform it's in. And then sometimes you just don't find the problem, which is why your customers end up letting you know you have a problem to begin with. At the same time, you have all those complexities, you have more deployment options than ever before. You have things in your on-premise institution, you've got things in multiple different cloud providers, maybe you have a hybrid cloud platform that you're running. All of those things together mean, unless you're very careful, you end up with different sets of tools across each of these environments. And then, of course, now that you have all these tools, they don't interoperate together, which means you end up stitching this stuff together with a whole bunch of Elmer's glue, right? You get out your Elmer's glue and your hot glue gun, you put all the things down, you paste it together and you try to make it work, and it's a big pain in the butt. What we did with Oracle and what we're doing, and we're really announcing today, and we're going to show you what we have available now and what's coming very soon, is we took a step back and said, what if we could break down the data silos? What if we could enable monitoring and diagnostics across all tiers of your stack, not just individual pieces? Why can't we support cloud native and your on-premise, or cloud native on-premise and other cloud providers? As well as offer interoperability, not just between our tools, but between our tools and all of our third-party providers as well. So with that in mind, you might want to wonder, well, what is it about Oracle? Why would Oracle be able to do this better than other providers? Well, we think we have some unique advantages. And this is not just because we have the coolest logo with a big O in front of it. It's because we've been doing this stuff for a very long time. Oracle has been operating at all these different layers of the stack, at the OS layer with things like Oracle Linux, up through the middle tier with things like WebLogic, at the database layer with Oracle Database, as well as our other database technologies, things like MySQL, things like x10, et cetera, all the way up to the application layer where we actually offer things like our traditional on-premise applications like eBusiness Suite, PeopleSoft, JD Edwards, as well as our entire portfolio of Fusion applications in the cloud. The fact that we have operated every layer of the stack, as well as the fact that we've been operating these SaaS environments for our customers, which has forced us to build and develop these tools ourselves. And then combine that with the reality that we already are the leader for data management for all of these enterprise customers. It provides us a unique position, both in terms of the assets that we've created over the years, as well as the customer experience and the customer feedback that we've gotten. And so we've combined all of that together, and we've created a new Oracle Cloud Observability and Management platform. So we've got some really cool graphics over here on the side of the screen, but let me tell you a little bit about what these different services do. First thing to remember is that everything I'm talking about here works, whether it's from natively in OCI, whether it's across your on-premise portfolio, but it also works across other cloud providers' platforms, whether it be, say, AWS or Microsoft Azure. We have an integrated platform that combines all of these individual services and makes them work together seamlessly. We're really focused on operating at all the different levels of the stack, whether it's at the application layer, whether it's at the middle tier, whether it's at the database layer. We have tools that operate at all of those and unify the view. Again, across both cloud native, so whether you're using the coolest new technologies, writing things in Go, operating on Kubernetes, or whether you're still, say, hey, you have an application that's predominantly a WebLogic Java EE-based application. Our tool set unifies all of those applications together. And as we've been building that same ecosystem of tools for ourselves, we've prioritized interoperability between what we do and what the other third-party tools are. And we'll go through later some demos as well as some testimonials and some context around what we're doing in the partner ecosystem to make sure that no matter what tools you use, we work together extremely well. So now let's dig a little bit into each of these services more. So our logging service, we launched very recently. It's live and available now. And we focused on a few key things that differentiate our logging service from what you might be used to on other cloud providers. So the first one is that we've really centralized log management. So whether it be your audit logs, whether it be your application logs, your infrastructure logs, we have a single place for all of your logs to come together. We then built on top of that an intuitive rules-based action system, which enables you to convert your logs into whether it be time series data, alerts, or notifications, or subsection those logs and then store them in different locations. And then the last part is that we've built all of this on top of open standards. So we leverage FluentD for ingesting these logs, and we're also 100% compatible with the Cloud Native Computing Foundation Cloud Events 1.0 standard. We didn't stop with logging because we also know that customers need deeper insights into those individual logs. And that's where our logging analytics service that's now live comes into play. The way to think about this is that logging is really about streaming this data around, storing it for you, archiving it for you. Logging analytics, think of it as an easy way to dig deeper into the contents of those logs, to visualize what's going on so that you can quickly derive insights. And it's also an easy way for you to take action on a huge heterogeneous set of different log formats. So for example, no matter whether you're using an Apache log format or whether you're doing some custom JSON stuff, or whether you have any of the other 250 different log formats that we support natively, we can automatically ingest that stuff and then visualize it and bring insights into that platform across all of your different services. So this is very abstract. We've got some cool visuals on the screen. Rather than just hear me talk about it, what we're going to do is hand it over to our highly qualified and esteemed product manager, Mugiz Minhas, who's going to take you through a demonstration of logging and log analytics.
Thank you, Clay. In this first demonstration, we will show you the capabilities of our logging and logging analytics services. We'll begin at the enterprise dashboard. This is the custom dashboard that I've created, bringing together my most important applications, database servers, along with all its telemetry in one unified view. On the dashboard, we see an HTTP timeout in our eMedia application. Let's go see what's happening here. Clicking the alert lands me directly into the OCI logging search page with all of my context pre-filled in for me to begin my investigation. Looking down below, I see the actual result that triggered my alarm. The specific error being shown is an HTTP 408 error. When I look at the log line, I can see the exact front-end host, request IP, the latency, and the detailed error message. When I ingest a log into OCI logging, my log is automatically parsed and made searchable, which is powered by a FluentD agent where every event is normalized into the common CNCF cloud events format. So it looks like our application front-end server returned an error that says exceeded timeout threshold. This could be caused by a variety of different issues in my stack, for example, issues on the backend, or the load balancer, or the network. I want to trace down exactly where this request from this specific IP address went through my entire stack to see at what points things broke. So I'm simply going to take the IP address and paste it into my search box. I'm now able to see results from my entire stack as it relates to this IP address. I can now easily trace exactly what happened with this request. I see the request coming into the front-end machine receiving that request and the load balancer doing the assignment of that request to one of our load balanced infrastructure components. Then I see a variety of network traffic that looks a little bit unusual going through the application and ultimately a backend timeout. OCI logging allows us to easily integrate and visualize hundreds of thousands of log lines with just a few clicks. I want to drill into what's going on in my BCN flow logs. When I click on the Visualize tab, I can now see the aggregated count of every single inbound and outbound request across my entire network. It looks like there is an abnormal amount of traffic happening here, so I need to understand a little more about what's going on in my OCI network. I'm going to escalate this question into OCI Logging Analytics. OCI Logging Analytics uses advanced visualizations and applied machine learning to find the needle in the haystack, even among very large amounts of log data. Right now, we are looking at all the BCN flow logs from our compartment, which is almost 1 million rows. If you look at a single entry from one of these logs, we can see that we've parsed and enriched the information from these logs, enabling us to do things like classify the action, which in this case was a packet reject. Why don't we see if packet rejection is part of a network problem? By dragging the action field into a group by window and resorting our chart, we see that vast majority of packets have been accepted, so packet rejection is not a networking problem. Let's explore a different question. Perhaps we have some unusual traffic coming from servers that are not normally part of our network traffic. Let's resort all of the log records to look at the IP addresses generating traffic. We see we have some noisy telemetry servers here, but those are not unusual, so that's clearly not our problem either. We can further get a quick view of the trends in traffic from our servers by simply looking at another visualization, and we don't see anything unusual in that trend charts either. Note that all of this analysis is happening automatically. We have many other out-of-the-box visualizations available, which we can put into a dashboard like this one. But let's get back to our troubleshooting scenario. We saw the problems were not packet rejection and were not unusual traffic from our public servers. So let's use some machine learning to search for one-time anomalies. We are looking at the output of a link analysis, which automatically stitches together the data. This table shows a summary of network traffic from each source to each destination over a period of time. Now we've still got 600,000 rows of logs, which is too much. So let's use some additional machine learning called clustering to identify the patterns of network traffic. This cluster chart shows trends in network activity over time from various sources to various destinations, with the size of bubble indicating the amount of data being transferred. I'm going to refactor the data by total bytes transferred and eliminate the small transfers. And what I will ultimately see is the needle in the haystack cause of our problem, which is a large data transfer from an MP4 file from a web server called Collab Server 1. We can then drill in and quickly see the exact 2 file transfers that caused the network problem. It's now clear that network contention caused what at first appeared to be a set of application errors. So what we have seen here is how logging and log analytics can help you quickly and easily aggregate and search logs and use machine learning and analytics capabilities to do problem diagnostics without requiring you to be a data scientist or even have deep domain knowledge about the logs you are analyzing.
Integra LifeSciences has created a video that I want you guys to take a second to watch that really showcases what they're doing with our logging platform.
Integra is a leading global provider of regenerative and neurological devices and technologies. To have a secure, observable, and reliable infrastructure is essential in making sure we are able to develop, manufacture, and distribute the quality products to surgeons and patients who need them. We've had several less than successful attempts at our cloud migration with other vendors. As of last February, we are fully on the Oracle Cloud platform, and it really has exceeded our expectations. The monitoring and logging capabilities give us unprecedented visibility into the operations of the system, and the 24/7 alerting allows us to get out ahead of problems and fix them. With a cross-tier view of applications, database, and infrastructure, we can now resolve performance issues in minutes instead of hours. Our multi-tier application stack is operated by a team of just 10 DevOps engineers. OCI helps keep our systems running all the time so that we can continue to enhance the quality of our patients' lives each and every day with our products.
So we've gone ahead and covered the first couple of services in our overall observability and management platform, right? We covered logging and we covered log analytics. I want to talk about 3 new services that are actually in limited availability now. So these are not generally available yet, but we have many customers using the early access versions of these, and these services will be available in just a few months. The first one I want to talk about is application performance monitoring. You might be used to different APM solutions from different providers. The thing to understand that's unique about what we're doing here is that it covers from the end user all the way down to the individual server. And we've done deep integrations with our technology across different layers of the stack to make that possible. It also supports synthetic monitoring, which means that you can simulate transactions for proactive monitoring. You don't just have to wait for reactive things to happen in your environment. And it also supports distributed tracing. When you combine application performance monitoring with our database management service, that's when you really start to unlock the power of our platform. So our database management service today is just focused on Oracle database and supports things like fleet monitoring and management. We have a performance hub, which automatically aggregates performance data across your database services and enables you to optimize the performance of them. Enables real-time SQL monitoring, as well as automating a whole bunch of database administration tasks that you might want to do across your fleet of Oracle databases. But we haven't stopped there. We also have a service we call Operations Insights. And this really today is focused on 2 things. One is around capacity management, which is about enabling you to understand what is the capacity of your databases and other servers that you have today? How is that growing and changing over time? And how do you need to think about that in the future? We also combine that with a SQL warehouse, which think of this as a long-term historical view of all of your SQL queries that enables you to see changes in performance or in query plans over time to debug emergent kind of performance changes in your overall application. And so once again, we have really cool visuals, but we're going to switch it over to Mugiz, who's going to show you application performance monitoring. He's going to show you database management and operations insight, all working together to solve real customer problems.
In this demonstration, we will show you how you can quickly diagnose performance problems using a combination of application performance monitoring, database management, and operations insight services. So now we are back on our enterprise dashboard. We can see that our software store monitor runtime is throwing an alert in the upper left corner, and down in the lower left we can see that the AppDex for our software store is also low. AppDex is a standard measure of user satisfaction with application performance. Let's debug what's going on. The software store application consists of a variety of microservices that sit in front of an Oracle Autonomous Database. As you can see, one of our synthetic monitors has thrown an error, so we'll click on that to drill down. Looking at the last 6 hours, I can see that most of our synthetic test runs ran in an acceptable amount of time, but some of them were quite slow. Let's look at one of the individual slow runs. To do this, I'll navigate to the Application Performance Monitoring Synthetic Monitor page, select the Software Store Checkout Monitor, and view its run history. The synthetic monitor runs every 5 minutes. I'm going to pick one of the runs that ran too long and drill into the trace details for that run. APM stores every single trace from every single user doing every single transaction in every one of our applications. Right now, though, I'm only interested in the traces for this particular transaction. In looking at it, it's clear that one step is taking most of the elapsed time. The trace details give us a clear picture of every step of the transaction, beginning with the end user's browser request, through the various microservices, ultimately down to the database. We can see that time being spent is largely in a database call, which happens to be an update statement. Next, I need to investigate this SQL to see why it is taking such a long time. I can see the SQL ID, the database URL, the ATP ID. I will now move to the database management service for further investigation. StoreET is an autonomous transaction processing database which holds our software store application. Performance Hub is Oracle's integrated diagnostics and tuning toolkit and leverages the same best practices used by Oracle Enterprise Manager. We start by ruling out systemic issues such as CPU overload, which we can clearly see is not the case. The main activity chart is a picture of total database time servicing foreground requests. Here we can see a repeating pattern of large CPU usage in green, but it is the orange areas that show time spent waiting or application inefficiency that are most interesting to us. Ash Analytics is an interactive tool that allows us to do multi-dimensional analysis of database activity. By refactoring the Ash data by wait event, we can see that roll-log contention is occurring regularly but intermittently. The SQL identified by the APM service, which begins with the number 2, is spending a lot of time in application waits. There is another SQL immediately above it that is consuming a lot of CPU time. We can use the Blocking Sessions tab to see current and historical incidences of roll-log contention. The SQL statement triggering the APM alert is an update statement that typically should execute in milliseconds, but is being blocked. The blocking SQL is doing a select for update on the same table, blocking rows, and it's that one that is using a lot of CPU and taking too long to execute. This is the actual root cause of the problem. In our Operations Insight service, we have a feature called SQL Warehouse, which, as the name suggests, is a long-term SQL store for performance and trend analysis of your SQL statements to help you identify trends and proactively troubleshoot and mitigate SQL issues. Looking at the performance statistics for that particular SQL, we can see that our average response time has gone up well over 100%, which is obviously a cause of concern. And in the Insights column, we can see that our SQL has degraded by over 50%. So while it maybe wasn't always bad, it is certainly bad now. Looking at the two performance charts below, it's obvious that the performance of the SQL has degraded substantially in recent times. One obvious question we might ask is whether the SQL is now being executed much more frequently than before, but a quick look at the history shows that the rate of execution has not changed. So our next step is to look at the execution plan of this SQL statement, and when we do that, we can see that this is a fairly straightforward execution plan which will not scale with growth in data. As the size of the underlying table grows, the SQL will get slower. A simple solution to improve the SQL is to add an index. You can do it manually, use our advisors like SQL Tuning Advisor, or this being an autonomous database, you can simply enable the auto-indexing feature. And indeed, that's exactly what we did. After the index was created, the performance problem went away. Now when you look at the dashboard, you can see that the database CPU utilization has gone down and the AppDex score has gone up. So what we've been able to do is leverage a combination of application performance monitoring, database management, and Operations Insight services, a variety of telemetry and analytics out of the box to debug a performance problem that showed up in an application but was caused by something else.
Let's hear more from Kingold, who's using our platform to solve some of their observability problems.
Hi, I'm Stephen Chin, CIO of Kingo Group. We at Kingo are committed to providing exceptional lifestyle choices for people living exceptional lives. And that's why we've chosen Oracle's Observability and Management solution to watch over our most important applications and their respective cloud environments. We're now getting real-time insights into residents' app usage with automatic alerts of anomalies, and 95% of critical issues are resolved before users are impacted. We also now have the capability to identify code-level performance issues 10 times faster. We couldn't do this without the built-in machine learning technology of Oracle's solution, which automatically correlates app telemetry with back-office events and logs. Oracle's Observability and Management solution is essentially a guardian angel to our cloud, keeping us safe and making my team members happier as he takes the dull and repetitive work away from them. And above all, it helps us deliver mission-critical services and great experiences to our customers.
We've been working with many customers throughout the development of these services. So while we're just now launching some of them and the others will be available in a few months, We actually have had customers in production on top of these platforms for a long time, and we've been taking all of their very valuable feedback to ensure that we're providing not just a good platform in general, but one that really solves the most difficult customer problems. You can see here a few more customers that are taking advantage of our login and log analytics platform, as well as the deep investments that we've been making in application performance monitoring, database management, and operational insights. I want to talk about one last service before we let you go. This one is our Service Connector Hub. And so this service is really about bringing together a lot of the functionality provided by these other individual services. So what the Service Connector Hub does is it provides seamless integration with other industry tools. It gives you a visibility into your data movement, so you can easily track which data sources things are coming from, as well as how do you want to route that data into other OCI services. And it also supports things like taking near real-time actions. You can easily archive your logs to different object storage buckets, or you can use Service Connector Hub to integrate, say, our logging subsystem with other third-party providers. To show you more about how this works in action, Mugiz has one last demo that he's going to showcase integration with PagerDuty and Grafana and how that works with our logging products and Service Connector Hub.
Okay, so in this final demo, I will show you the interoperability features of our new platform. So here we have a simple video encoding application running on OCI Compute. You can see that the compute instances are integrated with the monitoring service for metrics and with the logging service for logs. I'll first show you how you can create your own custom integrations. So let's see how you can take logs to a data analysis tool of your choice using the Service Connector Hub. Simply create a service connector, set the source as logging, and target as streaming. The Service Connector Hub lets you manage and monitor data movement between your OCI services and to a Kafka-compatible third-party tools. Logs are now flowing from logging to our streaming service. Customers can use Kafka connectors for popular observability and management tools to access the data. Now let's see how OCI provides out-of-box integrations with some of the leading industry vendors. Today we are announcing a new OCI Grafana plugin that lets you explore metrics and logs in a single view. Let's try this out with a simple scenario. I have set up an alarm in the monitoring service that triggers when memory utilization goes above 40%. This will send me notifications via PagerDuty, Slack, and email. So let's see what happens when this alarm is triggered. As expected, I receive notifications from all three channels. I will click on the Slack notification and drill in further. I can see that it is a critical alarm and that I need to investigate further. I'm going to click on the link to the Grafana dashboard link in the alarm body. Quickly, I can see the problem. The memory utilization metric has begun to spike. Let's find out why. I will select the time range in which memory utilization started to increase. The metric chart not only zooms in, I can see that the log panel has also refreshed to show logs corresponding to that time period. Quickly scanning through the logs, I can see that the root cause is a new build that the engineering team deployed, which introduced a memory issue. This is a good example of OCI's Observability and Management platform's seamless integration with tools like Slack, PagerDuty, Grafana, and how this reduced the time to resolve the issue to a few minutes, something that otherwise could have taken a long time. In summary, you can continue to use the tools that you have invested in and easily integrate with OCI's Observability and Management platform without changing your operational posture.
We also have the CTO of Grafana, Anthony Woods, to share a little bit more about our integrations and the partnership we have with Grafana.
Oracle provides high-performance infrastructure globally, and Oracle Cloud Infrastructure enables customers to deploy tens of thousands of nodes for their hyperscale applications. Grafana helps those customers visualize and observe at cloud scale. Grafana Labs is the maker of open source Grafana, which has become the world's most popular dashboarding technology. Oracle Cloud Infrastructure's Grafana plugins allow customers to easily leverage their existing investments in Grafana dashboards and plugins without adopting unfamiliar new tools. The plugins for Oracle Cloud Infrastructure are the product of joint engineering efforts and certified by both companies. Zero learning curve means engineers can use well-known, familiar tools from Grafana for their Oracle Cloud Infrastructure and applications. When deployed into the cloud, Grafana plugin integrations are seamless. We have Grafana dashboards for Oracle Cloud Infrastructure up and running in 5 minutes. Strong teams, both companies to help joint customers every step of the way. Customers can download the plugins from the Grafana marketplace and leverage support from both companies. Cox Automotive, owner of brands such as Kelly Blue Book and Autotrader.com, are using Grafana with Oracle Cloud Infrastructure today. We're seeing a positive trend in adoption and will serve more customers together.
We talked earlier about how multiple different customers have been working with us to make sure that our platform solves all of their issues. In addition, we've been working with many different partners. So we've been working with PagerDuty, we've been working with Twilio, as well as Grafana to make sure that our ecosystem plugs directly into their ecosystem. In addition, we've also been working with different system integrators, companies like Wipro, Mythix, and Capgemini, to ensure that our platform is usable not just by end customers directly, but by third-party partners who need to manage the most complex customer workloads. Thank you all for taking the time today to spend a few minutes with us and learn about these new services. So as we said before, logging, log analytics, and Service Connector Hub are all available today. Application performance monitoring, database management, and operation insights are going to be available very soon. If you don't already have an OCI account, please go to oracle.com and sign up for a new free trial. It's very easy to do, and you can take advantage of all the services that we have now. If you're already a customer and would like to get early access to application performance monitoring or database management or operation insights, please reach out to us. We'd be very happy to give you early preview access to those things. Thanks for taking the time to spend with us today. Until next time, stay safe and have fun.